Welcome everyone and welcome to our sessions on artificial intelligence and its applications. So in the previous sessions we just saw about some basic topics about what is machine learning and how to implement our first machine learning program, that is our linear regression. So what we learned in linear regression is pretty simple. So whenever you have some data, you can take all those data in. If you want to predict any data, so what is in the meaning of prediction? So if you have the previous values, you can predict your future values. For example, if you had the years of experience and salary data, so you can predict for any other future values of years of experience and salary data. So what we did in the previous sessions were pretty simple. We were just able to predict the data between our years of experience and salary. So if we had X is equal to years of experience and Y would be the salary. So this would be a single variable linear regression. But what we'll be doing now is we'll be doing a multiple variable linear regression. What is a multiple variable linear regression is pretty simple. When you have a form of equation that is nothing but Y is equal to mx plus c, where Y is your nothing but your like the dependent variable or the predicting variable that you are predicting, but your mx is nothing but m is nothing but your slope and c is nothing but your intercept. But what we'll be doing here is we'll be doing an equation which is of the form y is equal to m1 x1 plus m2 x2 plus m3 x3 plus c. So basically what we are telling is the data that we are taking is not dependent only on one variable, that is x. So you have multiple variables like x1, x2, x3 and x4 and obviously your intercept. So it depends on a lot of factors, not just one factor. So in the data set that we'll be using, so you can see the data set. In the previous case, we just had two columns, that is nothing but one is X and the other one is Y. So when you had years of experience, you could have predicted the salary. So in this data set, so this data set is called as 50 startups data set. So what is this data set exactly telling you? First we'll understand. Before understanding that, one thing we need to take into consideration here is the data is not a single thing. That is, X is not a single column. We have multiple columns of X and one column of Y. So what we should understand from this is pretty simple. So X need not be one variable. You can have multiple values of X and multiple columns of X, which will be able to predict your Y. So what is this data set is pretty simple. So this data set is about the startup data set in USA. So you have your startup data set in your USA. So what is this telling you is what is the expenses that each and every startup is undergoing. So you have your expenses in different columns. So what expenses is, whenever a startup is trying to work out, so they have to spend on R&D. So what is the amount of money that they have spent in R&D is first column. Second column comes in administration. So how much of money are the startups spending in terms of administration is the second column. But in the third column, we have something called as marketing spend. So what is marketing spend? So how much are the people spending in marketing? So these three categories we understood. These three are numbers. But in the fourth column, if we are trying to do something, so we have some text data or string data. So it is New York, California, Florida, New York, California, Florida. So in this data set, we can clearly see that we are comparing startups which are based in New York, California and Florida throughout our entire data set. Okay. So what we are trying to understand is how a startup is spending some money. So how much of money is the startup spending in R&D? How much of money is the startup spending in administration? So how much of money the startup is spending in marketing? So all these things are nothing but our different X values. So this is X1, X2 and X3. But here we have something called as a state. So state is nothing but telling you which state is the startup located. So in many of the data sets, we need to consider whether we need to consider this column for our prediction of profits. So last column we have is profit. So how much of profits is this particular startup making if it is spending this much amount in all these three domains, that is in R&D, administration and marketing spend. But one thing we need to consider is, should we also consider this column which is containing states? In many cases we wouldn't consider, because what we would like to do is, if we had another column called as name of the company. So name of the company is another column like XYZ, all the name of the companies. So we wouldn't have considered that particular column. So why wouldn't have we considered this particular column? Name of the company doesn't have anything to deal with the profit. So it is all based upon whether they are spending in R&D, administration or marketing. So similarly, if you want to consider the state, so which state is the startup placed, but actually thinking strategically, yes, the states does matter, because each and every state will have different financial condition, each and every state will have different rents for the startups, each and every state will have different category of people who will be working there. So majority of the factors we are trying to consider. So what we will be trying to do is, instead of using this particular string, so we can't give a string to our machine learning algorithm. Can we give? So can machine learning algorithm understand what is New York? No, it doesn't understand. Machine learning algorithms take in only numbers. So be clear with this principle. So anytime you are doing a machine learning program, if you have the string with you, either you need to convert the string to numbers or you need to eliminate the strings. Only two methods are there. You can't put the string into the machine learning algorithm. Very important. So the factors that we will be considering here are R&D spend, administration and marketing spend. Yes, that is also there. But state also we should need to consider. So what we will be doing is, we will be converting all these states into numbers. So let New York be, like, we'll convert them into numbers. So then they can be put into our algorithm and find out what is the exact result that we get. So the entire, the main usage of this particular data set, or the main thing that we are able to determine using data set, is profit. So our Y will become this profit. So Y is nothing but the profit that we need to calculate, that the startup will earn. So we have the data of 3 columns. So using 3 columns as well as the 4th column, which we will convert that particular string into our numerical data. What we'll do is, we'll try to easily predict the values of profit. So this is also a linear regression. What we are trying to do, again, each and every point on the particular thing, so that is nothing but x1, y1, x2, y3 and x3, y3. We are trying to calculate the distances between each and every point that is there on the whole, the points that are plotted. So after calculating the distance between the points between plotted, we'll square the distances, we'll see which is the minimum distance out of this entire thing. So the minimum distance line will be the best fit line. So you can consider the minimum best fit line. That is the actual line that will be passing through. From that we will be able to determine the future profits, or any value if you give, so we will be able to determine the profit. So this is how this project is going to be. This is a linear regression problem only, where we are trying to find out the exact best fit line for all our data. So this is what we will be doing. Okay, so this is the data set. This is called as 50 startups data set. What we'll do is, we'll open a Python program and we'll start working on this particular thing. So we have our data set. We'll be performing a multiple linear regression. What is the thing that we need to do is pretty simple. We need to code a program for linear regression, like how we did yesterday. So we'll code a program for linear regression, but the thing that we'll be doing is pretty simple. We will be trying to find out the multiple linear regression here. So one thing is pretty simple. We need to import our packages, import pandas, import numpy. So why we need numpy, I have been telling you the whole ways, because whatever data that you read using your CSV file, they are like millions of data, 100 numbers of data. You can't store them in regular lists or regular arrays. So what you try to do is, you need to store them in numpy lists and numpy arrays, which is nothing but which can store large number of numbers. But nowhere we are using it, because when we use scikit-learn, automatically the data will be converted into your numpy format. So you don't need to convert anything. When you just use your scikit-learn, automatically the data will be converted into nothing but our numpy formats. So this is very important to understand. I will show you where exactly we are dealing with numpy. So we'll see what is the type of data that we are getting. So we imported pandas and numpy. So that is one part of the program. Next, we'll again keep a name called as data sets. What does the data set do? It is nothing but it will read our CSV file. We need to read our CSV file like the previous example. Name of the CSV file, it is pretty simple, 50 underscore startups .csv. So if it is in the same folder, that is nothing but if your Python program is in the same folder or same directory where your CSV file is there, then you need not mention the whole location. Otherwise, you need to mention the whole path or directory of the entire thing. So that is one very important thing that you need to consider again and again. So this is how I have given my path. So if it is already there in your particular directory, you don't need to give the entire path. So that is one part. So we'll check whether we have got the data set properly or not. We'll just print the data set. So we are printing it. So we'll save it as a Python program. After printing it, we'll see the data being, many a times you'll get the data squeezed because there will be a lot of data. You can click on that button again. So if you didn't get it, I'll show you again. So many of the time, if you want to print that whole thing, it will be squeezed into text lines because a lot of data will be there. It doesn't want to confuse you. So you can press that and you can load all the data sets. So we have loaded the data set successfully. So that part is done. What is the next part that we need to do is pretty simple. So after loading the data sets, we need to split the data set into columns. So second part is nothing but splitting the data set into columns. So how do we do split into columns into X and Y? So we'll name it as X. So what is X? X is everything except your last column. So we'll consider each and every column except the last column. So how will you do it in terms of your pandas is pretty simple. Dataset.iloc is the function. But if you want to consider everything except your last, it is colon -1. So if you are doing colon -1, you are telling it is nothing but we are selecting everything except the last column. But we will need the values of it because we don't need the headings, we need only the values. So this is how your X is getting split. So where did we use NumPy is the next question that everyone tried to ask me. See, whenever you're converting your dataset.iloc.values, the data will be converted automatically into NumPy array. So for example, if I want to print out type of X, which is telling me what data type my X is storing. See, it is telling me it is a NumPy array. So whenever you are trying to use dataset.iloc.values, all the data will be converted into your NumPy array. To give it your scikit-learn algorithm for making your nothing but your linear regression, all the data must be in the form of NumPy array. Without NumPy array, you can't do your mathematical format. That is nothing but you can't do your regressions as well as machine learning algorithms. So NumPy array is the basic thing that happens automatically. You never use NumPy on your own, but if you are giving data, for example, so you are not using any data set, I am giving data as example 1, 2, 3, I am using a list to for my machine learning algorithm. Now then you need to convert them as np.array. So this is how you convert them into arrays. So very important, whenever you are using this dataset.iloc, automatically it gets converted into a NumPy array. That is why you never used it in the first program. So automatically it gets converted. So all the data that you give into scikit-learn for machine learning must be in the form of NumPy array. So this is very important. Okay. So that is how you use your nothing but your NumPy array. So then you have datasets.iloc, which is nothing but you need to select the last column. So how do you select the last column? Tell which is the column that you will be using. 0, 1, 2, 3 and 4. Fourth column you need to select. So how do you select the fourth column? Colon comma 4 will select you the fourth column. Dot values will give you what is the values that it is taking. So we'll just try to print out your Y. Also we'll try to comment this. We'll try to print out Y. So what we'll do is we'll try to print it out. Yeah, so this is the Y data. So what is Y having? You can see it here. This is nothing but the profit. 192.261.83, 192.261.83. So that is how we are printing out all the Y data. So very important. So we understood how to read the columns and rows. So you can refer the previous example where I have explained extensively regarding how to select your rows and columns and why are we using this principle to select our rows and columns. So next what we will be trying to do is pretty simple. So we have our X and Y. So whenever we want to try to print our only X data, so okay, we'll try to print our X data. Whenever we are printing our X data, what we can see is we have nothing but our data, which is nothing but our R&D spend, marketing administration and marketing spend. All these three are numbers. But this one is nothing but our data which is in the form of your string. So whenever you are passing a string to your machine learning program, it doesn't work. So very important, we'll convert the string into numbers. So how do we convert strings into numbers? Is using label encoding or hot encoder. So what is this hot encoder and why should we need to encode data is pretty simple. So if you want to give these strings to your machine learning algorithm, it doesn't accept. So how will you convert your whole data into your particular example, or how do you convert your data into an encoded format? I will tell you that how actually encoding works. So as you can see here, we have our column that is nothing but we have our column state, which has basically a combination of three data. So what is the three data which we have? New York, California, Florida, New York, Florida, New York. So it is nothing but a combination of three data, New York, California and Florida. Since this data is in the form of a string, so we need to do some kind of encoding. So what is this encoding is pretty simple. So what we will try to do is, using this column, we will try to add three more columns. Okay, so three more columns are telling you it is nothing but your new columns being added to the data set. So what are these new columns? Are nothing but empty columns which will have data. So how do we fit in these columns and how do we convert this particular things into number is pretty simple. So what it will do is it will create three new columns. So one column, two columns and three columns. So how it will assign values is, if New York is there, it will add three columns. So what it will do is, in this first data, New York is present. So it will give a 1 to this New York. In the first data, California is not present. It will give a 0 to California and 0 to Florida. So if New York was present in this particular row, so what it will do is it will assign 1 to this New York column. So these three columns are created separately. What is happening is, whatever data that we have in this particular state variable or in this particular state column, that is nothing but we have three data, New York, California and Florida. That three data will form new columns now. So after forming the new columns, if the data is present in that particular row, the 1 will be appended to the data. In this second data, what we have is, we have California. So but we don't have our New York. So New York will become 0. California will become 1. And then your Florida will become 0 again. Okay, so now next coming to Florida, New York is 0, California is 0, then your Florida will become 1. So this is how your data is getting encoded. So what we are trying to do is, we have this data as a string. So since the string cannot be used in the algorithm, so we will see how many category of data is there in this column. In this column, if we see, we can see only three category of data. What is the three category of data that we have in here is nothing but New York, California and Florida. So we have New York, California and Florida, but these three data to represent in the form of numbers, it is difficult. So what is the solution that we have is, we will create three new columns using the categories of data. Since we have three data columns here, that is nothing but categories, New York, California and Florida, we are going to create three new columns. So what is the column that we are trying to create? New York, California and Florida. So after creating the three new columns, we need to fill in the data. So in that particular first column, so if we have our first row, second row and third row. So in the first row, if New York is there in this particular data, so in New York is there in this particular data, since we will add three more columns here. So in the New York column, if the New York is there in the state, so it will add 1 to it. Okay, so then California and Florida, it will add 0 because they are not there. In the second column, which is there, California. So in the second column, California is there, it will add 0 to New York, 1 to California and 0 to Florida. And in Florida, third column, if you have Florida, so it is going to add 1 to Florida, 0 to California and 0 to New York. And at the end, what it is going to do is, it is going to remove this particular data. So why is it going to remove this particular data? Because that data cannot be used in our machine learning algorithm. So it is going to remove the data and it is only going to keep these three data for our machine learning program. So this is what you need to understand with the help of hot encoding. Very important to understand about hot encoding or any encoding for that matter. What we are trying to do is, we are trying to convert our strings into numerical data. So very important. Okay, so we'll try to use the inbuilt function to which will encode our data. So we have an encoding format from sklearn itself. So you can use this from sklearn.preprocessing. Import one hot code encoder. So one hot encoder is the name for this encoder. So what it is trying to do is pretty simple. You are able to encode your data. So what is encoding? Converting your strings into numerical format. So that is what is your encoder. So we'll import this, and we have another thing called as from sklearn.compose import make column transformer. So what we are trying to do is this will do its job. So what is one hot code and one hot encoder? It is nothing but encoding our string into our numerical values. But what are we encoding, guys? So one thing you need to keep into consideration is this entire column should be encoded. Okay, after encoding this column should be removed. Then 3 new columns called as New York, California and Florida should be added. Wherever New York is there in this place, it should give 1. So wherever California is there, it should give 1 in the California column. So all these processes are done with the help of this make column transformer. So we are transforming our column. So that is what we are doing. So these two are very important. So what I'll do is I'll create a new variable called as A. So what A does is, it does make column transformer. So we will use this make column transformer from scikit-learn. Okay, make column transformer. What will it do? So it will one hot encode our data. So what is one hot encoder? Encoder, it is the name of the encoder. What it is doing is, it is encoding our data. So we have to add something called as categories, which is nothing but auto. So what is categories is, which should it assign 1, which should it assign 0 and which should it assign. See, since these are 3 datas, how will it do the category? So how will it form the column? In which order does it form the column is the next question. Because your California can also come first, your Florida can also come first and New York can also come first. So which order are this column created? We have left it to the function to decide, because we will put it as auto. We can see at the end what is the column that is created. So we will put it as auto. So very important to understand, we are converting our string to our numerical data. For that we are using one hot encoder. But we need to do this for our entire column. So if we don't do this for our entire column, then the whole point of doing this is waste, because we need this operation to be done for this entire column and 3 new columns should be added. For that we are using this make column transformer. So two libraries we took from sklearn. So one is one hot encoder and the other one is make column transformer. So what we will do is, we will create a variable called A. So what it will do is, it will use this make column transformer function. So make column transformer is, it is transforming a column. So how is it transforming a column? By encoding. So what is encoding? It is converting your string into data. So what data is it converting? Numerical data. How is it converting, or what category is it converting, or which column is it putting first column, second column and third column? That is nothing but, how is it assigning the numbers to the columns is nothing but auto. So we have given it as auto. So it can select the automatic format. So then which column should we perform this operation? So that is very important. So which column should we perform this operation? 0, 1, 2 and 3. So third column we need to perform this operation, because third column has our string data. So we need to mention the third column here. So then we will finish the encoding. Okay, so what this is particularly doing is, we are doing our column transformation. So in column transformation, what are we doing? We are converting our variables into numerical. So we are converting string into numerical values. So why are we doing this? To use it in our machine learning algorithm. Then why we need categories? Because we need to create new columns like New York, then create new columns like California. How is that order going to go about? Whether New York is the first column, California is the second column. So we are keeping it as auto, because it will only select and it will only put the order of the column. So that is very important. So then what we need to do is, we need to use a function, or we need to use a option called as remainder. So what is remainder is, once I convert all this to numerical data, I add three new columns here. But what is going to happen to my old data? What is happening to my R&D spend, administration, marketing spend, profits? Are they getting disappeared, or are they getting deleted? No. So what we do is, remainder is nothing but, after doing this column transformation, what should happen to your data? That is nothing but the other columns. So we'll use it as pass through. So what is pass through telling you? Pass through is telling you that whatever data is there in the other columns, let it be as it is, don't change anything, just add these three columns, nothing but encode your data, add it to our original data. So that is what it is telling. So very important to understand, we are doing hot encoding to convert your string to your numerical values, but we need to do it to our entire column. That is why we are using column transformer. Here we have a variable a, which is making column transformation by encoding. So encoding it is doing, to be what it is encoding are column number 3. But after encoding, what will happen to our remaining data? That is nothing but R&D spend, administration, marketing spend and profit. They should remain as it is. So that is why remainder is nothing but pass through. Pass through is nothing but allow them to allow them as it is, don't make any changes to the existing one. So this is with the basic thing that we understood. Okay. So then what we will be doing is, since we have this column transformation, to which data should we transform our columns? To X data we need to transform our columns. So we have our X is equal to A dot fit. So why do we need to fit is the next question that everyone has. So why do we need to fit is pretty simple. This A is nothing but an empty variable, guys. So we are not splitting anything. Only if we give it to some kind of data, it will be able to perform that operation. So this A is nothing but an empty function. So an empty function, if you give some data only, it will be able to make some things to work, right? So if you have an addition function, so it will take A and B, so then it will add A plus B. Only if you give A as 5 and B as 10, so then only it will make some sense. So that is why this is just a function. In order to push our value, so what is our value? It is nothing but X. A dot fit underscore transform is the function. So we need to fit our data to transform it. It is nothing but X. So what is happening? X is storing the transformed version of our data. So what is happening? It is encoding the data, performing the whole operations to the column. That is how it is encoding the entire thing. So what we will do is pretty simple. We will try to print that X. So we have transformed it. What we did, we converted our string to variable. After converting our string to variable, we did an operation of adding 3 new columns and removing that state column which contained only the string value. So converted into the string, converting string to numericals and doing it for the whole column. So that is what we did, but we fit that data to X. Why did we fit? Because X is the data that we need to do those operations. This is nothing but an empty function. So when we fit the values to the X, all these things are happening to X. So if we try to print out X, you can see clearly what is being happening. Okay, so there is an error. What is the error? That we will see. Remainder is equal to pass through. Yeah, one thing we need to do is, once we open this thing, so we need to open another bracket, because we have this particular concept here. So okay, so we need to open one more bracket here, because this bracket is ending here. Okay, done. So this encoder will close here. Yes, so we are encoding, and this only one bracket we need to include it. So that was the thing that we had forgotten. Okay, so now we will get the output regarding what? So we are getting the data. So here you can see clearly that wherever our data is there, it is getting added, and see wherever our string was there. So we got our string removed. What was our string? Nothing but the state which had New York, California and Florida. But here we have three new columns that is being the input. So what is the 3 new columns? So which is nothing but the individual state data. So if New York is there, one will be appended to New York. If Florida is there, one will be appended to Florida. But which is New York, which is Florida, we can compare in this data set. So when we see this 47,1784, 47,1784, this is the first column. Okay. So then we have 136165, all this thing belongs to the first column. But instead of New York, we have 001. So this third column will be the New York now. Then we have California. So in California, we have, this is the second column. So California belongs to the first part. So third column is New York. First column is California. Second column is Florida. That is how your data is getting categorized auto. So since we have used auto, so it is automatically categorizing. So this belongs to New York. So this is California and this is Florida. So whenever you want to consider your data as New York, in the third column you need to give it as 1, that is New York. In the first column, that is California, and in the second column it is Florida. So how did it do is it categorized based on alphabetical order. So California is nothing but comes first because C. Then you have Florida, which is nothing but F, which is coming at the second index, and the third one is nothing but your New York, which is coming at the third. So very important. It is done with the help of your alphabetical order C, F, and N. So it is done based upon alphabetical order. So this is how your data needs to be encoded. You can't use your string data. You need to use your data that is nothing but your numerical data. So very important to understand how your data got transformed into numbers. So based upon the alphabetical order, California, Florida, and New York. So that is how your data got transformed. Okay. So after doing this, our data is transformed, done, majority of the tasks are done. But what is the next task that we need to do is pretty simple. So we need to use our data set, which is nothing but our training and testing data set. So we have our sklearn model, which we have already learnt earlier. So which is nothing but from sklearn. So we'll comment this off because we don't want to print it again. From sklearn dot linear model import linear regression. So this is the linear regression function that we will be taking in. After taking in, we will name it as regressor is equal to linear regression. So I am giving an alternate name for my linear regression, so I can use it anywhere else. So instead of typing linear regression again and again, so I can use this function again. So linear regression. Since I have my data that is nothing but linear regression, so what shall we do? So similar to our previous program, we have our data ready now. Till now, what did we do? We were making sure that our data contains numbers, so that is why we did some encoding. So after encoding, what should we do now? We need to fit our data to this also. To make our linear regression model understand which is X and which is Y, we need to fit our data to our linear regression model also. So how will we fit our data to our linear regression model? It is nothing but regressor.fit. So I've already explained you what is fit. It is nothing but we are telling that this is the data X and this is the data Y. So before doing that, I have to do one more thing. I have to split my data. So how do I split my data? From sklearn, so I need to split my data into training and testing. From sklearn dot model selection, so import train test split. So what are we doing here? From sklearn.model_selection import train test split. What are we doing here? We need to split the data into training and testing. I have explained the concept earlier also. Why we need to split the data into training and testing? Because we have the data, we need to give majority of the data for training. So whether after training we need to see how best our data is getting trained and how best our data is getting, what is the accuracy of the data that is being trained? All those things we need to understand. That is why we need to split the data into training and testing. So we have in our splitting data that is nothing but our xtrain, xtest, ytrain, ytest. So this is our data. What we need to do is use this function train test split. So how will we split what data are we splitting? We are splitting our data x, y. So we can see here x and y is the data that we are splitting. So we need to select our test size also. Test size is nothing but how much of data will go into testing. So what is the thing that we'll choose is 0.20 is nothing but 20% will go into testing, rest 80% will go into training. Then we also need to select our random state. So in random state, what are we doing? We are nothing but telling that once we have a split data, that is nothing but once our data is split into training and testing. So these columns which are chosen for training and which are chosen for testing will remain as it is, how many ever iterations we do. So that is why we are choosing this random state. So I have taught you random state in the previous session. So please do go through if you are missing out on something. What random state is doing is pretty simple. Whenever you are splitting your data into training and testing, you don't know which data is splitting for training and testing. So to understand that is nothing but we choose a random state is equal to 0. What happens is whenever I choose random state is equal to 0, certain data will go to training and certain data will go to testing. But once I choose some random state is 0, every time that data will be only for, taken in for training and the remaining data will be taken in for testing. So that is why the testing and training data will remain the same. So that is very important. That is why you need to split your data into training and testing. So now we have our 80% data going into training, 20% data going into testing. So what we will try to do is we will try to fit our data. So what data we are fitting? X-train and Y-train. Why X-train and Y-train? Because we need to train our algorithms using the data X-train and Y-train. So we shouldn't train our algorithms using X and Y because we need to split our data into train and test. So after splitting the data into train and test, that training data we'll use it to train. Testing data we'll use to see how it is actually predicting our result. So that is the best thing that we can do. Okay, so now after fitting our train and test, what our algorithm is doing is our algorithm is learning. So linear regression algorithm is learning using your X-train and Y-train. So it will get the relationship between what is the relationship between your X and Y. So how your X1, X2, X3, X4 is varying with respect to Y. So that relationship it will obtain. So how it will obtain? It will find out the distances between your nothing but your points that are there in the graph as well as your line. So it will try to find out the best fit line by calculating the distance, squaring the distance, after that finding the minimum least square distance. So that is what it is doing. So till now what it did was we encoded the data, then we split the data, then we are giving it to our regular. So how we do it in a normal linear regression, that is how you are giving it to fit to make your linear regression train for your data. You are not training for any other random data, you are training it for X-train and Y-train because you want to train it using X-train and Y-train and you want to test it. Okay. So to check the accuracy of our model, so whether it has predicted properly, we will use Y-predict. So Y-predict is nothing but the prediction which will be made by this regressor model. So what will it predict? It will predict values for our X underscore test. So it is predicting values for our X underscore test. So if you have done this, then successfully you are able to predict the linear regression model. Okay, scale-learned.linear model, again L is a small here. So linear, L is a small lettered word here. So you have done it, but nowhere we are printing it. So we will print our Y underscore predict. Y underscore predict. So we'll try to print it. So this is our Y underscore predict. So these are the values that it predicted. So what did it predict? It predicted the values of X underscore test. So if I give an X underscore test is nothing but if R&D spend is this much, administration is this much, marketing spend is this much, what will be the profit? So the actual value is Y underscore test, but the predicted value is nothing but our Y underscore predict. So this is the thing that you need to understand each and every time. Why are we doing this like Y regressor.predict X underscore test is whenever we are giving X test data, our model should predict our Y test data. But the thing that is predicted by our model is Y predict. So what will we do is we'll try to put it in a data frame. So we'll print pd.data frame of. So this is pd.data frame. So what we'll do is we'll try to print that particular data. So what we'll try to print? Y underscore test comma Y underscore predict. Okay, so if we do this, we are able to print out two values. What is that? What is the Y underscore test and Y underscore predict? Again, we need to see what is the exact way. Okay, Y is caps here. So Y is Y underscore test, Y is caps, Y underscore predict is a variable. Yeah, so this is what we need to understand. So whenever we have our data, so this is our data, this is our original data, Y underscore this is our y underscore test. So this is our original data and this is our y underscore predict. So actual value was 103,282.38. So the predicted value is this. For what did it predict? For x test values it predicted. So what is the x test values? We'll try to print the x test values as well. So we'll try to print x test values. Here x test value will not be a single thing because you need to understand that x is not a single variable. It depends on multiple things. So what is x test? It depends on which region, whether it is belonging to New York, California or Florida. Then we have our R&D spend, then we have our administration spend, then we have our marketing spend. So if this is the location, so how to read this is pretty simple. If the location is nothing but it is California, Florida and New York, location is Florida, the amount of R&D spend that they are doing is 66,051, the amount of administration spend that they are doing is 182,645, and the amount of spend that they are doing in marketing is this. So what is the profit? Actual profit is this. Okay, so the predicted profits is close to this. So that is how you need to understand how your data is predicting your new values. So this is how your data is predicting your new values. Then the next question that I have is, I want to predict my own value. So I have my own value. So I will initialize another variable called as y predict one. I want to predict my own value. So how will I do is regressor.predict. So this is the function. What I will do in this is pretty simple. I want to predict my own value. So how will I predict my own values? First thing is location. So which location will I choose? California, Florida or New York? So I'll choose California. That is my first column will be 1.0. So this should be a list of lists because the input that is taken by your regressor function is a list of list. Okay, so the thing that it will take is California. So if it is California, what will be the other data? It is 0 again. And the Florida data will also be 0 and New York data will also be 0. These three columns are sorted. Okay, so if I am spending around 20,000, so 20,000 I am spending for my R&D, 10,000 I am spending for my marketing, okay, for my administration, and only I'll spend 3,000 for my particular, that is nothing but my values. So that is for my marketing. So 20,000 for R&D and my 10,000 for my administration and 3,000 for my marketing. So this is the thing that I will be spending. So I want to find out how much profit will I have. So I will print out this y underscore predict. So it will tell me what is the profit that I have. So to print this, I will comment out the previous one. So I don't want you to get confused here. So we'll try to predict this. We'll print it out. So I will be making $58,462 of profit every year if I have my location at California, spending 20,000 on R&D, spending 10,000 on my administration and 3,000 on my marketing. So if I want to increase this, so I will increase everything by 10x. So what will happen is, we'll see how much are we getting. So then obviously my profit percentage will increase. So that is how you are able to predict values for your own values. So if you want to predict for your own values, it should be a list of lists. You should give the data in the same order. That is nothing but California, Florida, New York, R&D spend, administration spend and your marketing spend. If you give that, then it will be predicting your Y value. So this is the example of multiple linear regression. So what did we do in multiple linear regression? We were able to predict the values of our different X values with respect to our Y values. So whenever we have different X values, we have Y values which are predicting what exactly are we trying to do. Is nothing but when we have our X values, how are our Y values being predicted. So here why we are telling it is a multiple linear regression is because we have multiple X values, not a single X value. In our previous case, we had only one X value, that is our years of experience, we were predicting salary. But here we have multiple X values. Here we are trying to predict our result, that is profit. But here in X values also we have state, that is New York, the state column which has different strings. So we encoded those strings into numbers so that it doesn't affect our machine learning program. So this is how you deal with real life data sets. So your task is to take in other real life data sets, perform linear regression, see how we are able to predict the data, which column to consider, which column not to consider. If there are strings, how to encode that strings. So all these things play a very important role while you are trying to deal with different data. So very important, you need to focus on this, guys. The last part that I am left out is pretty simple. So we need to find out what is the mean squared error. So what is the mean squared error? So whenever we have different points on the coordinate system with x and y, so we are trying to calculate the distance that is there between our line as well as our point. So whichever has the minimum distance, so that line is being taken as our best fit line. So how do we calculate whether what is the mean squared error of the best fit line? So what is the mean squared error? Nothing but the sum of all the distances between the various points to the best fit line. So the square of sum of all the distances of the points that are there in our x and y, between our x and y coordinate system and the best fit line, that is what our mean squared error. So to calculate mean squared error, we have our inbuilt function. So from sklearn.metrics, import mean squared error. So this is how we are importing your mean squared error. So after importing mean squared error, it is pretty simple. Print mean underscore squared error. So what mean squared error are we printing? So what are we testing out now? Y underscore test comma y underscore predict. So y, this is nothing but we are trying to predict what is the mean squared error that is there between our y underscore test and y underscore predict. So what is y underscore test? It is nothing but all the scattered point. What is y underscore predict? That is the straight line. So between the straight line that is drawn and between the data that is pointed out, that is the scattered points, what is this distance? What is the square of the distance? So that is my mean squared error. So if I try to print out this mean squared error, so this is the one that this is the data that I am getting. Okay, one second. From sklearn.metrics. So S should be there. So I have made an error. So this should be my mean squared error. So what is this? The sum of square of distances between the points as well as the best fit line. So this is the mean squared error that I am printing between y test and y predict. So again you need to understand what is y test. It is the scattered points that are there throughout my data. So what is y predict? So y predict is a straight line that is drawn through the graph. So these predicted points as well as the test points. So what is the square of sum of distances? So that will give you our mean square error. Again, if you want to print the accuracy, so how much accuracy is our linear regression predicting with? So there is a function called as regressor.score. So what are we trying to do is we are trying to test out the values that are predicted from x test and y test. So if we are giving x test, so how this function is working is, this is the data that I am giving x test. Okay, so then the regressor will predict another new data, that is y underscore predict. So if I give x test and y test, it will predict y underscore predict and will check how accurate this y underscore predict is with my y underscore test. So to predict my accuracy, dot score is the inbuilt function. So what it is doing is, x test is my data that I am giving to my regressor function. At the end, what it is doing, it is predicting y underscore predict. So that y underscore predict and this y underscore test will get tested. So what is the accuracy between these two values? It is trying to test. So we can see that the accuracy is around 93%. So this is how you can find out the accuracy of your linear regression. So linear regression, regressor.score, always will give x test and y test. Y predict and y test doesn't work because this is the data that we are giving to regressor to undergo the prediction process. So this is the data which our regressor is using to predict the some data. So after predicting it, it will check with this y underscore test to see what is the value that we are getting. So mean squared error and regressor score are two examples of some parameters you can use to check how accurate or what is the value of mean squared error as well as the accuracy of your entire algorithm. So with this, we end the simple topic of multiple linear regression. Again, I will be putting this particular program as well as our file, that is our CSV file. You can recheck the program, do with different data sets. That is how you practice. Okay, very important. And I hope you enjoyed this session, guys. So thank you.